So students, our aim is to learn about the chemical periodicity of the elements present in the periodic table. But before going to that, we need to learn about the how the periodic table was constructed. So you know that the periodic table was not constructed in a day. Actually, many scientists worked on it for a long time. They tried to put the elements with similar properties in same place. Periodic classification of the elements were needed to know about the periodic variation of physical and chemical properties of these inorganic elements. Up to the year 1830, only 31 elements were known to us, and up to the year 1965, only 63 elements were known to us. And now you know, in our modern periodic table we have 118 elements present. So you can understand it will be very difficult to remember the physical and chemical properties of all these elements individually. It was seen that the properties of all these elements actually vary periodically, or after a certain gap, a certain number, the properties of these elements actually get repeated. So for long, actually scientists were trying to put the elements with similar properties in same place. So in this lecture we will learn about the history of the periodic table. In that I will cover Daubernier's triad, Newland law of octaves, and mainly MENDELEEV'S periodic law. We will also learn about why we need the modern or long form of periodic table. This is because we will learn about the demerits of the MENDELEEV'S periodic law. So we will learn that the periodic table classifies all the known elements according to their properties, so that the elements with similar properties will be placed together in the same group, and while with different properties are separated from each other. So we need to classify the elements, to study the elements in a better way, to correlate the properties of the elements, and also to study the relationship between different elements. In the historic development of periodic table, Daubenier, who was a German chemist in the year 1817, made first attempt towards this classification, and he first could put some of the elements with similar properties in a group. Actually, he arranged the elements having similar properties in a group of 3, that is triad, and showed that the atomic mass of the middle element is actually arithmetic mean of the atomic masses of the other 2 elements. What is the meaning of that? You see here, I have, for example, I have kept here lithium, sodium and potassium, and you know the atomic mass of lithium is 7 and that of potassium is 39. So for sodium it will be 7 plus 39 divided by 2, that means 46 by 2, and it will be equal to 23. So this is the arithmetic mean of 7 and 39. So that means he told that these the property of these 3 elements will be similar and they could be kept in a triad. And he told about some other triads also, like chlorine, bromine and iodine, and calcium, strontium and barium also. But he could not explain about all the elements and could not put all the elements in triad form to explain their properties. Many scientists actually working on the problem that how to put the elements with similar properties in same place. So you see that in the 1817 actually we got the Daubernier's triad rule, and after that in 1865 that means after 48 years, an English chemist whose name was John Newland, he gave another law, and it was called as Newland law of octaves. And what he told? He told that when the elements are arranged in the increasing order of atomic masses, the properties of the every eighth element are similar to first elements. So you see here we have from lithium to fluorine. That means we have 7 elements, and they are kept in the increasing order of their atomic masses. Now in the 8th element, that means sodium, there will be a similarity in properties with that of the first element. That is, lithium and sodium will have similarity in properties like beryllium and magnesium, boron and aluminium, and so on. This was told by Newland. But in the Newland law of octave, actually scientist Newland could not put all the elements and could not show that all the elements follow his law, and also he could never left any gap for the elements which will be discovered in future. In the year 1869, just 5 years after Newland put forward his law of octaves, a Russian chemist actually named as Dmitry Mendeleev published a periodic table consisting of 63 elements. So 63 elements were known up to that period, and he could put all the elements in the periodic table he constructed at that time. This is Mendeleev's periodic table, and you see here he actually created some periods and groups. These horizontal rows, they are called the periods, and these vertical columns, they are called as groups. And in a group, actually the elements with similar properties were kept, and you can see he could create groups numbered from 1 to 8 and 7 number of periods. He actually left some gaps in the periodic table, which he told that these elements will be discovered later. But surprisingly, he could explain the properties of all these elements. So we saw that in the Mendeleev's periodic table, the horizontal rows in the periodic table are called periods. There are 7 periods in this periodic table numbered from 1 to 7. And there are groups. The vertical columns in the periodic table are called groups, and there are 8 groups in this periodic table starting from 1 to 8. There were subdivisions also in the groups as A and B. So using Mendeleev's periodic table, we could do the systematic study of elements. That means knowing the properties of one element in a group, the properties of other elements can be easily guessed. And then the prediction of new elements. So Mendeleev left some gaps, as you have already seen in the Mendeleev's periodic table, for the undiscovered elements. But he predicted the properties of those elements. He named them as Eka boron, Eka aluminium, Eka silicon. What is the meaning of Eka? Eka means after boron, after aluminium, and after silicon. And now we know that after boron we have scandium, and after aluminium we have gallium, and after silicon we have germanium. He explained the properties of all these elements, and it was very much surprising that these properties were matched when the elements were discovered. And another merit of Mendeleev's periodic table is that atomic masses of some elements were corrected by using Mendeleev's periodic table, like gold and platinum. If you look at the periodic table, you will see that the platinum was kept actually before gold, but previously it was thought that platinum is heavier than gold. So Mendeleev was the first person who told that no, platinum is lighter than gold. So noble gases were discovered after long. Mendeleev proposed about his periodic table, and you will be surprised to note that we could put the noble gases in a separate column, in a separate group, without disturbing the periodic table which Mendeleev proposed. Till now, I told you about the merits of the Mendeleev periodic table, but we should know about the demerits of this periodic table also, like the position of hydrogen. Position of hydrogen was not defined by Mendeleev because hydrogen is having the properties both as for the alkali metals and also as like the halogens. So it was very difficult to position hydrogen in the periodic table. And also the position of isotopes. You know, the isotopes are having the elements which have different atomic masses. So as in the periodic table told by Mendeleev, we should put the elements with atomic masses separately. So according to Mendeleev's law, we should put the isotopes of the same elements in different groups. But you know that is not possible because they are the compounds of the same elements. So this was a drawback for the Mendeleev's periodic law. And the another thing is that some anomalous pairs like argon, potassium, tellurium, iodine, cobalt, nickel, etc. For this you see here like cobalt, which is having the atomic mass 58.9 AMU, and nickel, which is having the atomic mass 58.7 AMU. So we know that according to Mendeleev's periodic law, we should keep nickel before cobalt, but actually it is kept after cobalt. So this is actually an anomaly, but he kept nickel after cobalt. The positions of lanthanides also it was not cleared in the Mendeleev's periodic table, and he also could not explain the cause of periodicity, that is the cause of periodic variation of the chemical and physical properties of the elements. And he kept some of the elements with similar properties, he kept in different groups, and also some dissimilar elements he kept in the same group. Like you see here, we have in the group 1 along with lithium, sodium, potassium, we have also copper, silver and gold, which is not expected. So these are mainly the drawbacks of Mendeleev's periodic table. So we needed some modern periodic table which will rectify all these demerits. And after that came actually scientist Bohr and scientist Moseley, who could explain the periodic variation of the properties using the atomic number of the elements. And this is the modern form of periodic table, and we will learn about this periodic table in our next class. So students, today we have learned about the historic development of periodic table up to Mendeleev's periodic table, and we now also know that why we need to form the modern form or the long form of periodic table. So today up to this, and see you in the next class. Bye bye.